You are welcome to GMAETS 41's YouTube channel. In this live class, we are going to be solving questions, right? These questions are physics problems. They are physics problems, right? So see the information written on the board. It's a workbook from UNIZIK University, Awka, Anambra State in Nigeria, abbreviated as UNIZIK. However, like I've always said, the fact that this question was taken from a particular school does not mean that it is only restricted to the school. This is something that applies to all of us, wherever you are studying, whether in Nigeria or outside Nigeria. In this particular live class, we shall be dealing with chapter 1, question 1 to 5 of that workbook. And chapter 1 is based on dimensional analysis. On this channel, I have taught dimensional analysis. There are works on it. And I'd like to say this to you, dear friends, please. I understand somehow that some of us, when studying our hard copy textbook, at times we don't just understand what is written there. I strongly encourage you, friends, to continue to study, keep studying, read and read, whether hard copy or soft copy. But whereby you have a challenge with what you are reading from hard copy, because I must also confess to the fact that there are some textbooks. The more you are reading, the less you're understanding what is there. It's all about the style of the writer, especially when the writer does not give, much passion into writing that textbook. Therefore, whenever you encounter a problem like that, please, my dear friends, the GMAETS 41 has built a video format of textbook for you, friends. On this channel, you see this channel, all the video lessons we have, and the works have been done such that it's as if we have a content per course or per subject. Once you show up, tune into this channel, go through a playlist or the homepage, you will see the topics arranged. So whenever you have a challenge with any of the course or subjects you are taking that are available on this channel, you're trying to study them in your textbook, or you go for your lecture and perhaps there's a challenge you couldn't follow up. Just come here, take a chill pill, and then come and enjoy absolute learning from this channel. We've got 5 questions we are going to deal with. Please share the link to this class to your friends. Tell them we have kicked off so that they can come and learn. It's possible that some of you may have soft questions we are going to treat, maybe using AI, artificial intelligence, as the case might be, here on the GMAETS 41. You've got your NI assistant, your natural intelligence assistant. So whenever you come here, you are certain that you're going to be drilled to learn and understand these concepts. I won't copy these questions on the board, please. I won't. Okay, so I would be very fast in finishing the 5 questions, and I'm hungry. I need to go and eat. As a matter of fact, food is even ready for me to eat, but I had to come and deliver this because of time. So let's move on straight, okay? Anything that needs to be written, I'll write it on the board. An object, that's question number 1. We are dealing with it. An object covers a distance x. So this is question 1. Okay, solution. I'll read the question first. An object covers a distance x in a time t, as indicated in the equation below. As indicated in the equation below, and the equation is x equal to at plus bt cubed, where a and b are constants. Where a and b are constants, what are the dimensions of a and b? What are the dimensions of a and B. So permit me, as usual, I use this for dimension. Dimension of A, we don't know. Okay, maybe let me transfer it below so that I can partition the board into 2. Dimension of A, we do not know. Dimension of B, we do not know. Permit me, please, to check the network situation. And please tell me, I hope you can hear me. I hope you can hear me. I hope you can hear me. I know I have this on fun. Let me change it to all messages. Yeah. Good evening. You're all welcome to join the class. Chinedu, good evening. You're welcome. All right. You can hear me. So let's move on. Please, like I said, I'm sorry. I can't copy this question on the board. And I'm apologizing to every other friend that is connecting from any part of the world or from any other school. UNIZIK student, already you have this workbook with you. So you have the question. But I guess I was not fast in dictating the question. And even so, at the end of the class, you can still come back and replay. Copy the question, okay? So this is what we have. And simply we are asked to find the dimension of A and B. This is quite a kind of critical kind of question. But like I've always maintained, recently, I think a few days ago, I released a video giving an introductory 2026 message to you friends. Whenever you are given a problem, one of the secrets of solving any problem in this life, whether academic problem or non-academic problem, is your ability to understand the foundation of the problem. Once you know the root, your problem is solved. Like we said, this is a dimensional analysis problem. We are asked to find the dimension of A and B. And look at what we have here. Now, from the foundation of problems on dimension, when you study dimension, there are these 2 key things you ought to know about dimension that will help you to solve this question. One of it is, we are told that x is equal to this whole term. It simply means that the dimension of x is equal to the dimension of this whole thing. This is the first thing you have to bear in mind. Video lessons covering all of these concepts are available on this channel. Please reach out for them. Now, the second thing you should know to solve this problem, because from what I'm saying, this problem will lead us to simultaneous equation. We have AT plus BT cubed. There is a principle under dimensional analysis that when 2 terms are added or subtracted, simply put, when terms are added or subtracted under dimensional analysis, they have the same dimension. So AT and BT cubed are added. Therefore, the dimension of AT and the dimension of BT cubed will be the same. So I'm going to use these 2 principles to set out a simultaneous equation. Then we'll blast the question. There is no time. We go. Now, dimension of x is expected to be equal to dimension of AT plus dimension of BT cubed. This is a concept you should know. So let us fix the dimension. X is distance from the question. Dimension of distance is capital L. That is length. Okay? And then that is going to be equal to, you come to this part, write out the dimension of these terms. We do not know the dimension of A. We do not know the dimension of A. That's what we are looking for. I will just write dimension of A times dimension of T. Dimension of T time is capital T. We know that. Then plus dimension of B, we don't know it. So I'll write it this way. Dimension of T, once again, is T. And this is raised to power 3. So I'll raise it to power 3. I shall call this equation 1 because there is nothing I can solve here. I have 2 unknown, A and B, in one equation. So I cannot solve it. I'll have to move further and set out the second equation using the second principle like I said. Always understand the foundation of your problems. You will love it. That is why I always tell students, don't be too quick to do, question. No. Understand the background. Then when any problem is given to you, like I've always said, if you follow through GMAETS 41's coaching, your examiners cannot be able to dribble you. That is the basic truth. At least not for the courses that I take you. They can't. They have no choice but to give in and allow you blast your A and first class. We move on. Now, the second principle is the fact that these 2 terms are being added. Therefore, their dimensions are the same. It also applies to the case of when they are subtracted. So, similarly, I will now say that dimension of AT will be equal to dimension of BT cubed. And if this is the case, I can fix up the dimension here. Dimension of A times dimension of T, which will be capital T, will be equal to dimension of B, and then times dimension of time. I'll raise it to power 3. I am going to call this equation 2 because once again, we have this one equation and two unknowns. We don't know the dimension of this and the dimension of this. But we know the dimension of time and we have fixed it. T is time here, take note. X is distance according to the question. And my problem is as good as solved. All I have to do is to solve these two equations simultaneously. I'm going to use substitution method. I want to make A subject to the formula from equation 2. Then what I'm going to get, which I will call the fake dimension of A, because it's going to contain an unknown. I'll substitute it into equation 1 and then solve. If you've solved simultaneous equation before, on this channel I've covered that. Using substitution method, you should be able to understand what I'm talking about. That's basic maths, you know. So from equation 2, dimension of A will be equal to dimension of B times T raised to power 3. I'm going to divide this by dimension, by this T. I'm making dimension of A subject to the formula. Mathematically, you see that the dimension of A will be equal to, come here, this T will, remove one T from this T cube, and so you have dimension of B multiplied by T to the power of 2. Let's call this equation 2A. I decided to call it equation 2A to tell you that I got it from equation 2. I will now substitute this equation 2A into equation 1, so that equation 1 will now contain one unknown. Let me check this part of the board because I'd like to write there now. Okay, thank you for letting me know the network is good, Chinedu. Think I'm going to manage this part of the board, looking at the aspect ratio of the board because of the streaming method. So let us substitute equation 2A in equation 1. So that implies that, come to this, you have L equal to dimension of A. We are going to fix all this term. Okay, which is dimension of B. I'm substituting for this dimension of A now using equation 2A. A alone, dimension of A is this term. Look at it. And you notice that in equation 1, the dimension of A is multiplied by T. So it's going to be times T. I'm using dot for the multiplication. Then plus dimension of B times T raised to power 3. This is cool. You can see now that you have only one unknown dimension here. This is BT raised to power 2 times this T raised to power 1. Just added it straight on to this one because this term and this term, they are exactly the same. And whenever you are adding the same quantities, what you just have to do, it's just like having one orange, taking all this BT cube as orange, one orange plus one orange. So you get two oranges. These are like terms, we can add them, and so you have 2 times dimension of B times T cube. This plus this is twice of any one of them. 1 BT cube plus 1 BT cube will give you 2 BT cube. So from here, I can now make the dimension of B subject of the formula, which is going to give us, now watch what I am going to do. I won't make use of the 2. Under dimensional analysis, you learn that constants, constant multiplier, constant divisor, constant addend, constant subtrahend. You don't make use of them in dimensional analysis. You kick them off. Learn more about them, please. In the description section of this live class, I have the video lesson on this concept of dimension. And then at the end of this live class, perhaps by tomorrow, you would see, if you still come back, you would see the end screen to all these lectures for you to take and understand them very well. Both the end screen and the info links, okay, will appear on this video. If you click, it will simply take you to the lesson. So we're going to drop this 2 because it's a multiplier. You don't use it in dimensional analysis. Therefore, the dimension of B is equal to LT raised to the power of minus 3. You know that you do not write dimension. Normally, we are not allowed to leave dimension in quotient form. So you move this guy up. All of these, I've explained them very well. So we have obtained the dimension of B. With this, we can now come back to this fake dimension of A because I had already gotten the dimension of A. I call this fake because we don't know the dimension of B in this case. It still contains an unknown dimension. So now we know the dimension of B, just simply come back and substitute to get the dimension of A. So this implies that dimension of A is equal to, I'm replacing the dimension of B in equation 2A and I'm substituting back there. Dimension of B, look at it. So this is going to be LT to the power of minus 3. You are multiplying it by T squared because this dimension of B is multiplied by the dimension of time. Therefore, dimension of A is equal to T raised by minus 3 times T will give you T raised by minus 2. So this is LT to the power of, oh no, this is T squared. Please take note. This is dimension of B times T squared. So it's T squared. Now minus 3 plus 2 will give us minus 1. And we are done with this concept. We are done with this concept. That's the solution to question number 1. So you see that your natural intelligence assistant, of course, you must build your natural intelligence. You have to build it. AI is okay, yeah, if you know how well to use it, because if you are dependent on it, it's dangerous. It ruins your brain. By the time you do any consultation and other things, you have to understand how this is being done. Visit GMAT 41, your NI assistant. I hope you understand what I've done here. But like I said, please, for detailed step-by-step explanation of the concept of dimensional analysis, visit the playlist of this channel. On the home page, you will see the video lessons already arranged course by course, subject by subject, according to the order, topics in which you are to learn these things. Just imagine that your examiner asks you, what does A represent and what does B represent in this? Assuming your examiner decides to go further to ask you that. From the dimension of A, this is LT raised by minus 1. Which physical quantity has this dimension? Velocity, because this is simply distance divided by time. So A is actually velocity in this equation. What does B represent? LT, that is L divided by TQ. Can find out, that's acceleration divided by time. Yeah, acceleration divided by time. That's what you get here. And acceleration over time, there is a quantity it defines. You can verify, okay, I think it's called either jerk, or something like that. You can find out acceleration over time. It gives one that quantity, but we don't study it in motion at this level anyway. And of course, I don't think that we actually deal with it much. We deal with distance over time, which is speed. We deal with displacement over time, which is velocity. We deal with velocity over time, which is acceleration. And then this secret one, acceleration over time. I think it's called, jerk also, but it's not part of our work here. So that's what this point represents anyway, right? Let's move on to the second question, please. You can copy or screenshot this guy. Let's move on. Hey, sir, please recheck. Anna, is there anywhere I made a mistake? I think where I felt I made a mistake here, I corrected it. I was using T instead of T square. I hope that's where you're pointing to. Thank you, if that is it. I appreciate. Please, whenever there is any silly error from me on the board, point it out. I'm only a human, understand that. I can be saying something correctly and write something wrongly. That's our human part. We are moving on to the second question, please. We are moving on to the second, okay, question from Chichi. L is the length or distance of the object. You are correct. Oh, acceleration over time. Yes, acceleration over time. That is what B represents. You know, if you break this guy down mathematically, although this is not really part of our work, but just for you to see, this is L T raised to power minus 2 times T raised to power minus 1. That is the mathematical interpretation of this. And L T raised to power minus 2 is acceleration. You are dividing it by time because T raised to power minus 1 is over time. So you divide it by time. So this B you are seeing, this quantity is actually acceleration divided by time. And like I said, I think it is called jerk also. Either jerk or jolt, you know, something like that. Yeah. Something like that. I've made a reference to something of that kind, I think under scalars and vectors on this channel. Yeah, scalars and vector, I mentioned that quantity as a vector quantity. I mentioned as a vector quantity. It don't take, it's been long. Let's move on to our second question, please, okay? Let's move on to our second question. I hope the network is still okay, because sometimes network can be frustrating. I'm going to be fast now in solving the rest of the questions. Question number 2. This particular question 1 is actually a technical question under dimensional analysis. If you don't understand dimension very well, you just might not be able to solve it. But I've exposed the secret anyway. Question 2. Pay attention as I dictate the question, please. By the way, in your manual, space was provided for you to solve what I just solved there. So you solve it, manage the space. There are some things you don't need to show. Yeah, there are some things like this step now, you really don't need to show it. From this level, this step, somebody should know if you simplify this, you have to get this. You have to get this. And from here, if you jump to this, it's not wrong. Because somebody that has solved up to this point, an examiner should respect the person to know that the person can actually make dimension of this subject formula. So that some of these things you really do not need to show up in your works if you feel like there is not much space. After that, you have a space provided, final answer. In that final answer, all you just need to do is copy out the dimension of this A, write it there, then shift your hand, can use comma or semicolon to separate. Dimension of B, write it out there in that space provided for final answer. Please, question number 2, it reads, the magnitude of induced electromotive force E, the magnitude of induced electromotive force E in a conductor of length L, in a conductor of length L, which rotates in a magnetic field B, which rotates in a magnetic field B, is expressed according to the equation below. Is expressed according to the equation below. And the equation is given as E equal to 1 over A, open bracket, pi, and then BL squared. According to the equation below, look at the equation. What is the dimension of A? What is the dimension of A? Now, let us see how we solve to obtain the dimension of A. Now, from this equation given to us, we are to get the dimension of this A. Sorry, the dimension of this A rather. This guy is electromotive force as defined from the question. This is magnetic field B as defined in the question. Under magnetic field, it meets this quantity. It's also called magnetic flux density or magnetic field strength. So to get the dimension of this A, we simply have to make a subject of the formula. Okay? So let us do that and see. If I make a subject to the formula, simple, we are going to get, you cross multiply, divide both sides by the quotient of whatever. Am I communicating? That is basic math. You should know how to handle that. So this is going to be pi BL squared divided by the electromotive force. That is what we would get if you make a subject to the formula. So to get the dimension of A, we need to know the dimension of everything we have here. Now take note, pi is a constant. Pi is a constant and is multiplying here, so we have to drop it. We are not working with it under dimensional analysis. It's a number, pure number, multiplying. So focus on this, this, and this. L is length, and dimension of length is length. So this guy is already in dimensional form. Because what we are going to do here now, dimension of A, we don't know. That's our problem. Now, we need to get the dimension of B. B is magnetic field. What is the dimension of magnetic field? See, somehow, some way, some of us may not have met that before. But this is why you should have basic understanding of change of subject of formula, substitution. In mathematics is very important. Now, I must tell you that I've not on my own worked on the dimension of magnetic field before. Yeah, that's the truth. I've not. Today is the first time I'm dealing with something talking of the dimension of magnetic field strength. But does it matter? It doesn't matter. If you take your mind back to magnetic field, you remember that we have a formula that defines the magnetic force on a charge, and that F is equal to QVB. It carries sine theta sometimes. QVB sine theta. That sine theta is a number, so you drop it. That formula is actually, let's do the analysis somewhere, please, because I only need to transfer the dimension of B here. That's the only thing I need. I don't need to show how I got it in the workbook. Now, force is equal to QVB. Almost all of us should be used to this formula. So if I want to get the dimension of B, it's going to be the dimension of force divided by the dimension of charge times the dimension of velocity. This is going to be the formula. Make this subject of formula. So from here we can get a dimension of magnetic field. Substitute the dimension of force. Force is mass times acceleration. So the dimension is mLT to the power of minus 2. Divide by the dimension of charge. On this channel, yeah, I've actually covered the dimension of charge. I remember while teaching, one of the GMAETS 41's private online student. Charge is current times time. So the dimension of charge is simply obtained from the dimension of current, which I use I for, times the dimension of time. So this is the dimension of charge. Multiplied by the dimension of velocity, which is LT to the power of minus 1. Now we can simplify this. I guess this L and this L will go off. This time and this time will go off. Because this is T times T raised to power minus 1. Apply the law of indices, it will go off. You are left with I in the denominator. So the dimension of B is N T raised to power minus 2. This I will go up. Going up, it will be I to the power of minus 1. This is the dimension of magnetic field strength, or simply magnetic field. So at least we have all learned it today. This is my first time of bringing it out. Most times quantities we deal with, we don't usually encounter that in our basic physics, Okay, we move on. The next is the dimension of electromotive force. We have to get all these dimensions, then we will now substitute to get the dimension of A. What is the dimension of electromotive force? Once again, this is an electrical quantity. In basic dimension, we don't go that deep into all these other aspects. In recent time, I started telling students of the importance of moving forward. Go into all the aspects of these guys, because an examiner can just test you on them. Besides, we have 7 fundamental quantities with their dimensions, so you can be thrown to any part of them. Now, electromotive force, you want to understand something, that it actually defines voltage. Yeah, potential difference somehow, because they have the same unit. So I will come from that angle. And we can actually refer to it in terms of electrical potential. All these are voltage-related quantities. So if I'm to get the dimension of electromotive force, I would have to go through electrical potential. And we know that electrical potential, let me say E now, which is the voltage, electrical potential, can use V for it if you want, is work over charge. Yeah, work done in bringing a unit positive charge from infinity to a point in an electric field. That is the definition. So to get a dimension of our electromotive force, dimension of voltage, dimension of electrical potential, dimension of potential difference, all of them are the same thing, is going to be obtained from dimension of work over charge. What is the dimension of work? What is the dimension of work? Sorry, can you hear me at all? Can you hear me? Please indicate. Can you hear me? Can you hear me? Indicate. Please, I hope my mic did not cut off. Can you hear me? All right, Chichi, thank you for responding. So the dimension of this guy will now be force times distance. So force is this guy. Look at it. mLT raised to power minus 2. Then times distance or displacement, which is L. So the L will multiply this guy. Dimension of work is mL raised to power 2 T raised to power minus 2. That's the dimension of work. It's the same as the dimension of energy. Divided by the dimension of charge, which is IT. Chichi, I saw you type something about Q is constant, right? Q is not constant. Take note from the question. Let me see. Yeah, we were the one that brought in Q, and I told you the reason why it came. So Q is charge, okay? Take note of that. And charge is current times time. Under electrolysis in chemistry, we meet it. Coulomb's law. Is it Coulomb's law? Under Faraday's law of electrolysis, yeah. Charge, Q, quantity of electricity is current times time. So you use the dimension of current and the dimension of time to generate it. Please, let's move on. With this, if this T goes up, this is going to give us that the dimension of electromotive force, voltage, electrical potential, potential difference will now be M L square T raised to power minus 3 I raised to power minus 1. So let me transfer it here. ML square T raised to power minus 3 I raised to power minus 1. This is the dimension of electromotive force. And I guess our problem is solved. Let's now substitute. It implies that the dimension of A from the equation given to us will now be equal to the dimension of B, which is n T power minus 2 and then I to the power of minus 1. Look at it. That's the dimension of B times our L square. L is already in dimension form. Divided by dimension of electromotive force, which is mL squared T to the power of minus 3 I to the power of minus 1. We can now simplify this guy. I to the power of minus 1, I to the power of minus 1 we go off. L squared we go off. M will go off. Now look at what we are left with. This is T raised to the power of minus 2 all over T to the exponent minus 3. Division law of indices. Take minus 3 up, it becomes plus. Therefore, the dimension of A in this equation is equal to minus 2, that is T raised to the power of minus 2. If this minus 3 goes up, it becomes plus 3, which of course would be minus 2 plus 3. And minus 2 plus 3 will give us 1. So, the dimension of A in this equation is simply T. And what is the implication? The physical significance of A in this equation. A is actually time. A is actually time. You were not asked to state the significance of A anyway, but just know that A is what? Time. Dimension is a very important aspect of science. If you take the full lecture on dimension, application of dimension, you will come to appreciate it. You can see how we are using dimension to find out what all these quantities, what they mean in real life. We are done with question number 2. Let us go to question number 3 now. Please finish up. Let me wipe. Finish up. Let me wipe. All that work. You've seen it now, Chichi. All this stress. I'm wiping this, please. You are not meant to copy this guy in your workbook. You are not meant to. It's just I use it as a way of teaching you instead of just copying those dimensions and fixing here. I have to show you how you get the dimension of magnetic field and electromotive force. So after all this whole work, you can see this small thing. That's what we are looking for. But anyway, absolute knowledge of basic maths, yeah, can help you to blast these things quickly. Please let us look at question number 3. And believe me, I don't think I would want to solve question number 3. Or should I solve it? Because the solution is already on this channel. We don't have time. Like I said, I want to go and eat. I'm hungry. If you're yet to subscribe to this channel, please support me. Support GMAETS41. Subscribe. Turn on your notification bell. Select all so that whenever I come on live or I upload any content, you will be personally notified. Share the video lessons of GMAETS41 to your friends, to your departmental WhatsApp group. I invite your friends to also subscribe. I'll appreciate that. This is a non-monetary way of supporting GMAETS41. If you go further to support GMAETS41 monetarily, if you appreciate what is happening on this channel, if you're really getting benefit from this channel, which I know deep down that you do, please, you can also support me monetarily. Support this channel monetarily so that it will grow. All right, and the effort that goes into it. Now, generator they use is petroleum burning in Nigeria here. You know how we find it so hot. Please, I'll appreciate. Become a channel member. We have our premium packages, platinum level, diamond level. Platinum level is below $2. Yeah, it's below $2. Okay, Nigerian currency is 2,000 naira, which of course you know is less than $2. Then we have diamond level. It's less than $4. Yeah, because Nigerian currency is 4,000 naira. It's less than $4. Please, I really appreciate that. I can send GMAETS 41 a one-time support, sending us super chats, super thanks, okay, and super stickers. Right now, you can even do that. In the comment section, you see a dollar icon. Click on it, follow the prompts there, and support this channel, please. I'll appreciate. Question number 3. Already solved. Already solved. Check out the channel playlist. Under dimensional analysis, you see it. Meanwhile, like I said, at the end of this, by tomorrow, I will place the info link. Just at this point, I'm talking about this question 3. The question is actually, a guitar is being used in a church service by the musicians. When the guitar strings are plucked, it was observed that the velocity of the plucked strings are proportional to the powers of the length L, mass M, and tension T of the strings. According to the relation is V equal to L to the power of A, M to the power of B, and T to the power of C. So exactly this question 2 years ago, I solved it on this channel. Just a 10-minute video or less. Okay? So you were asked to where K is a constant, so A and B and C are unknown. They are not known. So calculate the values of A, B, and C. Calculate the values of A, B, C. So reach out for it so we don't waste time on dealing with it here, please. I'm here to solve questions. And questions are already available on this channel. I wouldn't waste my time on that. Let's move on to question number 4. Let's move on to question 4. So I'll come back here. Question 4. Question 4. Meanwhile, just a quick guide. All you just have to do, fix up the dimension of this guy. This is velocity. So it's LT raised to minus 1. Drop this K is a constant. You have no business with it. This L is in dimensional form already. You maintain it like that. M is in dimensional form. You maintain it like that. This T is tension, not time. Take note. And tension is force related. So you fix the dimension of force there. And the dimension of force is M LT raised to the power of minus 2. M LT to the power of minus 2. Alright? So this T, that is tension, whose dimension is M LT to the power of minus 2. All of them will be raised to power C. So you distribute C to the powers. Use C to multiply each of the powers of M, L, T to the power of minus 2. Using power law of indices. Once you do that, simplify the right-hand side. Are you following right? Of course, in simplifying, you'll be using multiplication law of indices. The same base, pick one of them, add the powers. Once you are done, equate to LT raised to power minus 1. And of course, you compare the power of the same dimension on both sides of the equation. Compare and equate, then solve for the unknown A, B, and C. You'll be getting some answers like half, and minus half, 0, or something like that. Like I said, the solution is available, and I've given you the breakdown. Question number 4, please. Let me check the network situation before I proceed with question 4. Seems like network is disturbing. Permit me to boost this, please. I'm sorry, it seems like network interfered, so I had to boost the network. And once it's boosted, any one of you still available will automatically be reconnected. Sorry, I didn't know that the network can be so annoying sometimes. So I just explained, I gave a breakdown of how you solve this question. Let's move on to question 4. No time, please. It's possible you did not get me when I was explaining how to do that. Like I said, you have the video lesson already on that. So question number 4, I am going to dictate it, so we are left with just one question. In question number 4, we have this. Consider the equation. And what is the equation? Consider the equation. Question 4. Consider the equation V equal to U plus Ft, where U and V are the initial and final velocities respectively. Where U and V are the initial and final velocities respectively. F is force and T represents time. And T represents time. F is force. Verify using dimensions if the equation is correct or not. Verify using dimensions if the equation is correct or not. Justify your answer. So you are meant to verify whether this equation is correct or not. After that, justify your answer. Of course, in justifying your answer is given a reason why the answer you stated is correct or not. Why you think that what you obtained in your verification, in your proof, why you think it is correct or not. So let us solve this question. Let me check the network situation before I proceed to solve question number 4. Okay, I think you can see the board and you can hear me very well. So let us move on. We are to verify whether this equation is correct. Of course, you know we use dimensional analysis to test the consistency, how correct an equation is. So all we have to do is simple. Okay, write out the dimension of the quantity on the left hand side of the equation. Write out the dimension of the quantity on the right hand side of the equation. If this equation is correct, the dimension on the left and the dimension on the right will be the same. So let us move on without wasting time. I'm going to fix the dimension of this guy straight on. All of them have been defined for us. We know the quantity, so we can fix up. Dimension of final velocity is Lt to the power of minus 1. Dimension of initial velocity, it is still velocity, so it is Lt to the power of minus 1. Dimension of force is mLt to the power of minus 2. Mass times acceleration. Then times t. And t, the dimension, is capital T because it is time. Now, on the left-hand side, we have Lt to the power of minus 1. So I'm going to write it, and that's going to be equal to, I will simplify this part of the equation. This is Lt to the power of minus 1 plus, if I come to this side, T to the power of minus 2 times T. We're going to have mL T to the power of minus 1 plus mL T to the power of minus 1 if you simplify. Now, if you look at the right-hand side, this Lt to the power of minus 1 and mLt to the power of minus 1, you cannot add them. They are not like terms. They are not like terms. This m spoiled everything for us. This m messed up everything for us. So we can't simplify the right-hand side further. This is how the right-hand side is meant to be. This is how it is meant to be. So do you see that at the end of what we have done here, the left-hand side and the right-hand side, they do not have the same dimension. They don't. They don't. Therefore, this equation is not correct. It's not correct. Now, take note, assuming this m was not there, if this m was not here, you could have added Lt to the power of minus 1 plus Lt to the power of minus 1, and you will get 2 Lt to the power of minus 1. Drop that 2 because it is a multiplier. You now have Lt to the power of minus 1 from the left equal to Lt to the power of minus 1 on the right, telling us that the equation is correct because both sides have the same dimension. In that case, take note, when assuming this m was not there. Sadly, m is there in that dimensional analysis, so we can't add these two terms. Now we observe that the left and the right hand side, they do not have the same dimension. They do not. Now what did the examiner say we should do? Say verify using dimensions if the equation is correct or not. So I will make the conclusion, therefore, the equation, like I said on this channel, all of these works, they are there. I broke down everything, different aspects in which problems and dimensions can be asked. Reach out for the video lesson and take place. The equation V equal to U plus Ft is incorrect. Is incorrect. One can also say is inconsistent. Inconsistent. No correct. Here in Nigeria in our pidgin, right? It is not correct. Now your examiner say justify your answer. Who told you that this is not correct? What made you say it is not correct? Let us now justify. In justifying, I will write, this is because the dimensions on the left hand side, permit me to use LHS, and right hand side, RHS, are different, are not the same, are not the same, are not the same. That is not equal, i.e., that is not equal. So this is the justification of the fact that we stated that the equation V equal to U plus Ft is not correct. This is what justifies it. Different dimensions on the left, on both sides of the equation. We are now left with our last question, number 5. Question number 5. Please remember to like this live class once you join the class. Remember to like it, please. Or appreciate your like. When you like the GMAETS 41's video, you give YouTube the opportunity to recommend the video to other scholars, which is one key thing that GMAETS 41 really wants to happen. Let many students learn these things for what they are. I've always maintained that these things are 1 plus 1, and that's the truth. It's just all about you understanding the foundation of your problem. Yeah, these are problems, these are questions. Know the foundation, know the roots, know the origin, and from there, you can solve the problem. Here, I guide you to understand the foundation so that whatever question thrown at you, you can be able to catch your examiners, catch them red-handed. And of course, you blast the question, smash your A in the exam, in the course, and overall, you expect your first class. Last question, please. Remember, there are 5 questions in this chapter 1, which is extracted from dimensional analysis. So let us take the last question. The question reads, let me check the network situation. Okay. The rate of change of pressure with distance is expressed as the pressure gradient. The rate of change of pressure with distance is expressed as the pressure gradient, expressed by dP dx, expressed by dP dx. Express the dimension of dP dx. Express the dimension of dP dx. Let me read it again. The rate of change of pressure with distance is expressed as the pressure gradient, represented by this term you are seeing here, dP dx. Now the question said, express the dimension of dP dx. Get the dimension of dP dx. That's what the examiner wants you to do. You know, pressure gradient. Listen, whenever you divide any quantity by height, you call that whole term the gradient of the numerator. GMAETS 41 divided by height is the gradient of GMAETS 41. You, dear friends, divided by height is the gradient of you, dear friends. Understand that. I will soon be unleashing lessons on heat and mass transfer from chemical engineering departmental work, higher level, 300-400 level and 500 level works. You meet things like that under heat and mass transfer when you talk about Fourier transfer, Fourier transform equation, Fourier transformation equation. Yeah. See, there is a lot coming your way from this channel this year, like I stated in my 2026 message to you, friends. So it's just like somebody telling you the rate of something, which is that thing over time. The gradient of something is that thing over height. Take note. So this is pressure gradient. You are asked to find the dimension, express the dimension. So simple. I will go. Dimension of pressure gradient, which is dp dx, is simply dimension of our dp divided by dimension of our dx. And this is simple. What we are just interested in dealing with here, get the dimension of pressure divided by the dimension of height. Dimension of height already is capital L. We know that's no problem because height in this case is length related. What is the dimension of pressure? Remember, pressure is force over area. Now let us generate it. I would like us to do a little solving here, but it's just simply 1 plus 1. Dimension of dp is simply dimension of df divided by area. That is it. I can say dA if I want to punish myself further, but all of those are irrelevant. Can simply say it is dimension of force divided by dimension of area, because pressure is force over area according to Pascal. I think I'm correct, right? Pressure is force over area. So we go, this is now going to be, what is the dimension of force? ml t to the power of minus 2 as usual. What is the dimension of area? Area is length square, square length. So we have got the dimension of this guy. Now, what is the dimension of dx? Let's obtain it. Dimension of dx is simply length L. Therefore, it implies that the dimension of dp dx will now be equal to, fix up the dimension of pressure, which is this guy. Look at it. I'll fix it up, but I could still simplify this. I could simplify this. Oh, I don't have enough space. But if I simplify it, this is going to be m L raised to power minus 1 T raised to power minus 2. That is the dimension of pressure, please. I hope this has not cut off from view. I guess it has. Let me adjust the camera a bit. Good. Good. Let me adjust the camera to capture that part. So all I have to do is to transfer the dimensions of pressure and height to this equation here, and then we're going to have ml power minus 1 t power minus 2, then divided by what? Dx. And of course, our dx here, the dimension is L. Therefore, the dimension dp dx will be equal to, simplify this term. Of course, you know you're going to get m L raised to power minus 2, then t raised to power minus 2. This, of course, is the dimension of dp dx. I hope you love this work very well. You love what has been done for you. See that this is simply 1 plus 1. And this is the solution to your chapter 1, question 1 to 5, physics 101, extracted from dimension. Tomorrow we are going to move on to chapter 2. All right? And in chapter 2, it focuses more on vectors. Get ready for that. If you have not subscribed, like I say, subscribe right now. Turn on your notification bell. After subscribing and you click the notification bell following that, a menu will drop down. Select all. This is free of charge. The reason for that is for you to get all notifications from this channel. If I come on live, 30 minutes to my coming on live or whatever, you will be notified. That is if I schedule the class ahead. If I upload any content, pre-recorded video, a lot of them appear regularly on this channel. Even this night, one is going to appear on circular motion, just there about 4-minute video. You will be notified. If you do not turn on your notification bell and select all, you won't know what is happening on this channel. Yeah. And then remember to support this channel's effort and growth. Like I said, I love you guys. I appreciate all the things you're doing to support this channel. Monetary support, appreciated also. To do that, like I said, you can join the platinum level or the diamond level of this channel. You can also send a super thanks to GMAETS 41 anytime at your convenience. All right, I've told you platinum level is less than $2, less than $2. Diamond level is less than $4. All right, Nigerian currency, 2,000 naira, 4,000 naira. Then for super thanks, if you click below any of the GMAETS 41's video, you will see the thanks icon. Click on it, right? And then you'll see packages available, whatever that is convenient for you. YouTube will give you that option, okay? So you can send GMAETS 41 is super thanks, appreciation. That is a regular one-time support. For channel membership, diamond, platinum level is a monthly support. I'll sincerely appreciate that. Always take your studies seriously, and remember, like GMAETS 41 has always consistently maintained, you want to enjoy what you're learning, always seek for the foundation. And here on the GMAETS 41, I give you the foundation. I also teach you the shortest cut to dealing with some things. To have a wonderful night rest from here at GMAETS 41.